And today is the 28th.
We missed all that good stuff. Yeah, it's all right.
I know it. Okay, the volume of that parallelepiped is the area of the base times the height. Now, let's talk about the base first. One of the properties of the cross product of the two vectors is that the magnitude of that cross is the area of the base. Okay? That is the area of the base. All right? That parallelogram. That's what I mentioned when we did the cross. What we have to do is find the height. Okay? So, I'm not sure the best. Well, I'm going to go back to here, which means, okay, this is still recording that, so that's okay. All right, this is good. I was thinking that I had lost the recording, but I don't. Okay, so what we want to do is find the height. Now, what is the height? The height would be, we have to have a perpendicular to this base. What it would be the magnitude of the projection of W on that perpendicular. That would be the height. Check this out. It's a little complicated, but you guys can handle this, all right? Wow, this is so cool. The way that works, it's pretty cool. Okay. All right, here you go. Here's W. What I'm going to do is project W on to the cross product, which is perpendicular to the base. The cross product being perpendicular to these two vectors that determine the base. Their cross is this. That's the projection. That's U cross V. The height is the projection of W on that cross. Okay? This is going to be the height right here. It's the perpendicular distance from here to here. This vector from here to here is exactly equal to this vector here to here, which is the projection of W on U cross V. Right here. This and this are the same. The height is the magnitude of that vector. It's the magnitude of that projection. Okay? And when we did a projection on another, we said the magnitude of the projection.
We got to switch back.
Good call. Okay. The magnitude of that projection, this is the projection of W on U cross V. That is our height. Okay. Well, when we did the projection of one vector on another, remember what happened. When we did the projection of U on V, the magnitude was equal to their dot product, okay, over the magnitude of the vector being projected upon squared times V. Here's what we did. When we did the projection of U on V, we said that's equal to the dot product, magnitude of V, squared times V, or magnitude of V times the unit vector in the direction of V. Okay? That was the projection of U on V when we did that projection last week. Okay? This is how we did it. We said this was K, and we found out what K was using cosine of the angle. This quantity right here is the magnitude of the projection. It's the magnitude of the projection. That's what we did when we used the cosine of that angle. We found out what the length of that projection was, and we multiplied it by the unit vector in the direction of V to get our projection. Okay? Because that magnitude would stretch the unit vector out to be the projection that we wanted. Okay. All right, what do we have here? We have the magnitude of the projection of W on U cross V. That's our height. Let's see what we have here. Okay. The magnitude of the projection is equal to the dot product over the magnitude of the vector being projected upon, which is our cross. Okay? This is what our height is equal to. Okay? Everybody with me on this? Therefore, the volume of the parallelepiped, which is equal to the area of the base times the height, is equal to the area of the base is the area of that parallelogram at the bottom. What is that equal to? It's the magnitude of the cross. That's what the volume, that's what the area of the base is, times the height, which is right here. This is the height, magnitude of the projection, which is equal to, after we cancel those out, that volume is equal to W dot U cross V. This is called the triple scalar product. Now, there's one thing wrong with this. The one thing wrong with this is, depending on the order of things, and it doesn't matter which order you take these vectors, except if you switch these, W and U and V, on the cross product, when you switch them, you change their sign, okay? You change their sign. So to make sure we get that positive volume that we need, we'll take an absolute value here, okay? Once you take an absolute value, it doesn't matter which is U, V, and W. Any order will give you the same volume, okay? Doesn't matter what you count as your base, and the other two would be your height. So, here, okay, this is what we need, the triple scalar product. We're going to do one in a minute, but let me just show you this. I have Mathematica do it. Okay, so I use the actual numbers here, and what I had Mathematica do was the absolute value of the dot product of two of them with the cross of the other. And please note what you have to do here. You've got to do the cross product first, okay, which gives you a vector, and then take that cross and dot it with the other one, which will give you a real number. And what I've done, I switched the order of the three vectors, okay? First one I did W dot U cross V, and then I did U dot V cross W, and the last one here. No matter which order you do, you get 54 as the volume of that parallelepiped. And please note, in Mathematica, dot product, use a dot. Cross product, use this little X. It's a special symbol. Okay. This little X here for a cross product is right here. Okay? Use that for the cross product of two vectors. It'll give you the cross. All right? So what I did, I crossed these two, dotted it with this, took the absolute value, and every case, no matter what order we took, you get an answer of 54. Okay? Yes?
When you say dot, just looking at from where I'm now, is that just a period, or is that just hitting them?
Yeah, here, I'll show you. If you dot, let's take a dot product of something or other. 1, 2, 3, dot, let's do it right, dot, 3, 4, 5. Now what should we get for this dot product? We should get 3 plus 8, 11 plus 50. We should get 26. Okay, we get to 26. That's their dot product. Take the sum of the products, you get a real number. And if you take this and do this, do the cross, you should get another vector, 3, 8, 15, which I assume is correct.
My question is
Oh.
the dot, is that a period?
Period, yes.
It's a period, okay.
That's how I got it, yeah, period.
Okay.
That was your question, yes.
And on the keyboard, you have periods, and you also have, like, you hit the...
Yeah, you got a period here that you're using the keyboard, but you don't have the right X. I'm about 99% sure if you just use an X here, whoa, maybe it'll work. I doubt it'll work, but let's check it. No, it doesn't work. Okay. You have to use this X. Okay. Okay. So, as a consequence of all this, one other thing you should be aware of is that if you have these vectors in 3 space, yeah, this is tough for me to do that.
Maybe you just need another TV.
You know what? I need an assistant.
We should
That's
get
what
like
we need.
2 or 3 TVs in this room.
Well, how about
Yeah.
one whiteboard and 2 TVs?
Yeah, that would work. That would work. Actually, at 12:15, when we're doing math team, some company has given a demo of smart boards, where
Are they gonna have free food?
they have free food over there. Yeah, somewhere, wherever it is. We're having pizza.
It's a difficult choice now.
They're not all that smart, you know?
Well, I'm not sure.
They're
I
like
think-
average boards.
I think what happens, I think what makes them smart is they have memory. And whatever you write here is automatically saved somewhere here. I'm not sure how that works, but they're being demoed. But I said, I'm doing a math team, the heck with it.
I'd say everyone in the school has potential for memory, but not everyone is like, smart.
Yeah, that's true.
What they should do is have someone save the demo on the smart board and put it on YouTube, and you can watch it after.
Yeah.
Well, there's an idea. Wow, that's perfect. All right. One other thing I do want to point out,
Take out these chalkboards.
if we have U and V, like I said, the cross is yet another vector orthogonal to these two. This would be their cross. Okay. But I do want to mention the fact that the area of the parallelogram, okay, is equal to the magnitude of that cross. And that means that if you have this triangle, the area of the triangle, this is the area of the parallelogram, the area of the triangle determined by those two, okay, is half the magnitude of the cross. But what you should also realize is that if you do have a triangle, let's say where this side is the magnitude of V, and this is the magnitude of U, what's another way of expressing the area of the triangle? Well, of course, you have 1/2 base times height, the usual. Okay. You also have a hero's formula, which is the area is the square root of S times S minus A, S minus B, S minus C, where S is a semi-perimeter. Okay, this is a long time, it's rarely used, but if you have the 3 sides, it does work. But there's another way of finding the area of a triangle. If you drop this perpendicular down, you know the area of the triangle is 1/2 the base, which would be the magnitude of U, times this height, H. Well, how can we find the H in terms of the angle and the magnitude of V? We've got the sine of this angle is equal to opposite over the hypotenuse. And this tells us that the height is equal to the magnitude of V times the sine of theta. Okay? So, here's what we have. The area of a triangle, the triangle determined by 2 vectors, is 1/2 magnitude of U times H, magnitude of V, times the sine of theta. And this area is also equal to 1/2 the magnitude of the cross. And that tells us that the magnitude of the cross is equal to uv sine theta. Okay? This is so cool. Because what did we do before? We proved that cosine is equal to the dot product over the product of the magnitudes. That meant that the dot product, okay, is equal to magnitude of u, magnitude of v, cosine theta. It's amazing the relationship between these two. Okay? So, magnitude of the cross, uv sine theta, dot product is equal to uv cosine theta. Okay? This is the area of the parallelogram determined by the two vectors. The dot product is used for the cosine of the angle between the two vectors. Okay. We should do one. Okay, let's do one. Okay. What's that? Okay, no problem. Got it? Okay, let's do one. Let's find the volume of the parallelepiped determined by these vectors. U, let's say, is 1, 2, 0. Let's say V is 3, 4, 0. And let's say W is equal to 1, 1, 5. Okay? Go ahead. You guys do it. I want the volume of the parallelepiped. Wow. I don't like the way I'm drawing that. You guys didn't copy that drawing, did you? Oh, you are, Dave?
Is it wrong?
No, it's not wrong. It's just these guys are too close. I was going to just split this off some, but it's okay. It's not wrong. It's just. I don't like it. I'm going to try it again. I don't like that one either.
Too shabby.
Oh man, mine's really bad. So.
Yours is better?
No, it's bad.
I'm not afraid of
Yeah, mine's bad
It's,
too.
it's not easy.
No, it's a little planning though, and a little care, and you can do this fairly well. The thing you got to do is draw this, and then draw this one to look like this one. Shift it over a little bit, and you can do it. Okay.
I'm just like, I don't want to draw that.
Look, while I was drawing it, it made sense, but then you look at it once it's done and oof.
Problem is the way I've done these things here. Yeah, whatever. Okay. Okay, how we doing out there? Somebody with an answer? Uh-oh. Jared. 10, he says. You agree? 11?
Yeah, I could have just done something.
All right, let's take a look. Let's take a look. Okay, here we go. Doesn't matter the order we do this. I'll tell you what I'm going to do. Let's take U cross V. Let's cross these. Okay, this is going to be a vector ijk, so, and it's going to be a vector. And what you do, cross this out, you're going to get 0 minus 0. Okay, cross this out, you're going to get 0 minus 0. Great, and you take the opposite since it's the middle one. All right, let's hope we get something over here. We got 4 minus 6, negative 2, okay? That's the cross of those two, 0, 0, negative 2. The magnitude of the cross is 2. The magnitude of the cross is the area of this parallelogram that's formed by these vectors. That's what the magnitude of the cross is going to give you, the area of that parallelogram. Okay. The volume of the parallelepiped. Now, let's do it. Volume is equal to W dot U cross V. Make sure you take an absolute value, because you may get positive, you may get negative, but you will always get the right answer as long as you take the absolute value. So W is 115 dot 0, 0, negative 2. 0 plus 0, that's negative 10, absolute value is, and you get 10. 10 is correct. But I do want to point this out. 10 is right. Any questions on that? Yes?
So the formula you gave, it was over the magnitude of U cross V. So wouldn't it be...
Hold on. No, the volume is this triple scalar product. So what are you looking at? You're looking at this. Okay, here we go. Gotta be careful. This is the triple scalar product. These two canceled out. Okay, this is the triple scalar. Yeah, I can see where you would, because the way I wrote it. But this is the magnitude of the projection. That was our height, and what we had to do is take the area of the base times the height, and these two canceled out, leaving us the triple scalar product. Okay? Bless you. How's that look? Okay? Does that look okay? Once we knew that the cross was 0, 0, negative 2, and the magnitude of cross was equal to 2, which gave us the area of the parallelogram of the base, we didn't really have to do this, because in this case, I gave you two vectors in the xy plane, and the area of their parallelogram was equal to 2, magnitude of the cross. The third vector I gave you, 115, meant that the height of that vector above the base was equal to how many? 5. The z-coordinate of that vector, 5, gave you the height above the base, which gave you the height. So it was 5 times 2. I knew it had to be 10 as soon as this had to be, as soon as this was negative 2. Dylan.
Can you just go over the cross product again?
Yeah. On the cross, ijk across the top, and then the components of u here, 1, 2, 0, 3, 4, 0. And by the way, if you were to swap these and do V cross U, the 3, 4, 0, 1, 2, 0 will give us a 0, 0, positive 2. When you swap those two vectors and finding the cross, it takes the opposite of this. So it would be 0, 0, 2. Then what do? You cross this out, and you cross this one out, and you have this 2 by 2 determinant 2, 0, 4, 0. Okay? Once you cross the first column out with the top row. This is what David's symbol, this gave you, crossing that column and that whole row out. So what do you get when you do that? You do the main diagonal, which is this guy, 0, minus minor diagonal, which is 0. Then when you do the J's, this is the T, you cross this out and you cross this out. Now you got 1, 0, 3, 0. Main diagonal, 0. Minor diagonal, 0. 0 minus 0 is still 0. So you get a 0 there. Finally, and the last, and when you do the middle, you take the opposite, but the 0 still gives you 0, of course. You do this one, okay? Cross this out, cross this out. 4 minus 6. You do this first, followed by this. 4 minus 6 is negative 2. That's where the negative 2 comes in. How are we doing? Okay. Actually, we don't have that much left to do in this chapter. We got the vector stuff. And then tomorrow what we're going to do are lines and planes in space. It's pretty cool. Okay, it's good stuff. Yes?
Do we need a rocket?
Yes, we do. Although some of you guys looking at you in the morning, looks like you don't need anything to be out in space. All right, no. that was poor, huh?
I have a cold.
All right. Then we got some surfaces in space. We're looking at, did I tell you the test steps? I didn't? All right, here's what we're looking at. Next Tuesday, okay, next Tuesday will probably be test number 2. Oh, one more thing. Oh, I may have to change that. Maybe it's going to be Thursday. I don't think I'm going to be here Friday. Depends on a couple things. But I will let you know for sure by Wednesday whether I'm going to be here on Friday. Okay? I'll let you know for sure. Okay. Math team coming up a little bit. Pizza coming, hopefully. And we'll do some problems from last week and new problems this week. Anthony.
Is there anything preventing us, if you notice, on your vectors, if 2 of them share the same 0, they're on the same plane, like say I and 2 of them are 0, can you use the same logic we used for the shortcut?
Yes, you could.
Okay, so all right, make sure there's nothing, as long as
Good call.